Hi everyone, welcome to this video. In this video we want to look at the SRX device for Juniper. So it's similar to what we did for the Cisco ASA, but now we want to look at the Juniper SRX device. So this is the topology that we'll be using even for the Cisco ASA deployment and site-to-site VPN and all the setup that we did for that series. If you're not part of it, you can go back to my YouTube channel. We have videos where we went through a lot of implementations for the ASA, things like the site-to-site VPNs, remote access VPN, overlapping subnet for site-to-site VPN, multi-hub VPN, and of course clustering the ASA. So everything we did for the Cisco ASA, we want to repeat it for Juniper, because Juniper is also another very common device you will find in an enterprise network. Okay, so we also want to have hands-on experience with Juniper, and so that yeah, we just say what the difference is. Okay, definitely the technologies are the same, but the implementations are quite different. So this is the topology we're going to use for the setup of Juniper XRS. Okay, so let me grab my pen. So as you can see here, this device is so it's vSRX device. Okay, so we're going to be using this two device for the LADC. Okay, so this data center could be, you know, it's a private network basically. Okay, and you have your servers. It could be 1, 2, or 3, or 10 servers, and you have your own like private network within your infrastructure. Okay, so we also have the New York DC, which is the we also have the XRS device that is there. For the London, we just want to see how we can integrate the ASA with Juniper as well. So like site-to-site VPN between the ASA and Juniper, we'll see how we can implement that, and we'll see if there's any tweak we need to do on the configurations. Okay, and then when we are done with this, then we can start looking at, okay, let's say these users who work from home, they need to, you know, come in and access their resources in these different data centers. Okay, so we're going to do remote access VPN, where you come in through the LADC and then you want to access the various sites that exist. Okay, so it's just we try to have hands-on on Juniper as well, similar to what we have for Cisco. Okay, now for clustering in Juniper, which is like a high availability method for implementing Juniper devices, is almost similar to the way you also implement for Cisco. Then of course the syntax are going to be different in the way you configure it. Yeah, because this is Juniper, you have Cisco, they are totally different vendors, different syntaxes, but the process or the steps you need to implement clustering is it's similar. Okay, so this is the level. This is I call this the, let me grab my pen again. So this is like the low level design LLD. Okay, because here, as you can see, we are showing all the physical connections and the ports, you know, so this is low level design. But if you scroll down, so let me scroll down, you're going to see the high level design. Okay, so this is the high level design for the implementation of SRX within your infrastructure. So for the basic one, you are going to need 2 devices. Okay, you're going to need 2 XRS devices to implement, and for a cluster you can only have maximum of 2 devices. Okay, so it always have to be 2 devices within a cluster. Okay, yeah, so what do we need to build a cluster? The first thing we need is, of course, the control plane. Okay, because when you build a cluster, you are going to have, they are going to share the same, you know, routing instance, control plane, management. It's just going to be a single control plane. So we'll need to set up the control plane, make the device join the cluster, set up the control plane so that they see each other, and they bring both their routing system as one, operating as a single instance for the control plane. Then there's also something we call the fabric link. Okay, now the fabric link is similar to your Cisco ASA, which is like the states for stateless replication. Okay, for state informations per se. Okay, so the fabric link, which is what we also need to set up, it's what the two devices we use to replicate their state information. But in Juniper, I think they call it the real-time objects. Okay, real-time objects are like your MAC address table, your app table, your VPN sessions, your TCP sessions, UDP sessions. It's a lot of variables that needs to. So the thing is, if this device is primary and this is secondary, which is like an active standby implementation, then this is going to be doing all the forwarding. This device will be doing all the forwarding, and so it's going to build all the tables. Why this box at the bottom will be in the secondary. So what will happen is, if the traffic is going through the primary and it builds all those real-time objects, it needs to push it down to the standby. And the idea is, if this device should go south, right, this the secondary device should be able to pick up the traffic almost immediately with little or no downtime. Because if this device does not already have those tables or the real-time object, what happens is, if this device, maybe something happened, maybe due to power failure, it power cycles, and imagine you have over maybe 20 gig of traffic coming out of this data center, and this device for no reason reboot, then you're going to have a lot of user impact. Okay, this impact is going to be felt. But when you have the fabric link and there's real-time replication between the primary and the secondary, okay, then you might not see the impact when the primary goes down. Okay, so that's the purpose of the fabric link. Now the fabric link can also be used for forwarding of data traffic, right? Data plane traffic. So we're also going to talk about that. So actual internet traffic can go through the fabric link, and then we're going to talk about specific use cases where that could happen. Then of course, you need to set up the LAN connection, and you also need to set up the wide area network connections. Okay, so these are really what we need to implement clustering for the SRX device. Okay, so we're going to take them step by step. We're going to set up the control plane, set up the fabric links, right? We're going to set up the LAN connection. We're also going to set up the wide area network connection. Now, something else we need to talk about is, okay, clustering. Is it active or active standby? Like I said, it's also similar to the ASA. You know, the ASA, what you have is active standby. Okay, active standby, right? Now in the ASA, you can also have active forwarding. Okay, active. Now for that to happen, you need to have what we call the context, right? Context mode, or I'm trying to remember what it is called. Okay, context is like a VRF instance or an isolated instance within the devices. Okay, I don't want to talk so much about the ASA, but it's almost similar. Now per context, you're still going to have what? Active standby, right? So if I have context for, let's say, finance, okay, which is like a VDC, or depend on the hardware, there are different ways of, right? So let's say we have a context for finance. Okay, now we can say for finance, the context exists here and it exists here, but here will be the forwarding and here will be on standby. Okay, now within this box also, you can create a different context for sales or different department, and here will be standby and here will be forwarding. Okay, so it's almost similar to how the way Juniper is. Now for Juniper, they call it redundancy group. Okay, redundancy group. Now per redundancy group, you can only have active standby. Okay, active standby, not active. So the implication is, if this redundancy group, let's say redundancy group 1, we can say this firewall is active. Okay, then for this, we're going to say for redundancy 1, you are going to be on standby. or secondary, depending on how you want to call it. Then we're also going to create another redundancy group again. We say 2, and then we say, well, here you are standby. Okay, but here for redundancy group 2, you will be forwarding. Okay, forwarding or active. Okay, so what you end up achieving is that yes, traffic actually goes through both devices, but for different redundancy group. Per redundancy group, you can only have one active device and the other one on standby. Pretty simple, similar to the Cisco implementation for the ASA. Okay, now what that specifically means that the redundancy group, let me just call it ROTGB, is where you define who is the active and who is the standby device or secondary device. Okay, so that's the implication. So we will need to create this redundancy group, right? Determine who should be active and who should be standby. And how do you determine who is active and who is standby? You use priorities. Okay, priority determine who should be standby. So here I can say for redundancy group 1, your priority is 200. Okay, for redundancy group 1 here, your priority is 100. That automatically means this is the active device for redundancy group 1. Okay, why the secondary device will be the backup or standby for redundancy group 1. Okay, so priority is what helps us determine who should be active for a redundancy group. Now, another concept we will talk about is there's something called the rect interface, right? The rect interface is like a replacement for, well, it's not a replacement though, but it's almost similar to your aggregate Ethernet interfaces, right? Or in Cisco, what you call port channels, right? Let's say port channel 10 or bundle Ethernet, like for the NI case. Okay, so this is what the rect interface is. But why they call it redundant interfaces? For you to have a rect interface, you need 2 physical ports, one from the primary and one from the secondary. So what happens is this: we'll take this interface, and add them together as one rect interface. So we can call it rect interface 0. Okay, so same for this interface here. We're going to take both of them, and then we're going to call it rect Ethernet interface I think it's RTH 1. Okay, so it's not really a bundle, but it's just a way, it's Juniper's own way of saying these 2 devices play the same function or play the same role, right? Because you cannot take this and this as a rect interface. Okay, because the traffic and they play different roles. Okay, but you can have the interfaces. So for the LAN interfaces, you can combine those 2 interfaces and call it a rect interface, right? Same for the one link, but you can have 2 interfaces from different zones, in this case as rect interfaces. Okay, so something else we need to talk about is, now we are going to take this rect interface and we are going to tie it to the redundancy group. Okay, redundancy group. Okay, we're going to take this and tie it to a redundancy group. Okay, so we can say they belong to redundancy group 1. We can also say here you belong to redundancy group so we can say you belong to redundancy group 1. Okay, so this rect interface and this rect interface can both belong to the same redundancy group 1. Okay, so what that means is, if we say redundancy group 1, okay, I hope it's making sense. So if we say redundancy group 1, that this is the primary for redundancy group 1 and this is the secondary, what that therefore means is that for traffic going from this server, it will hit the Tor switch and go through the primary, okay, to the internet, right? That's the implication. Okay, now if we say that this device is primary for, okay, so now let's look at a scenario. Okay, just like we said, we take this to interface, we said you belong to rect 0, and we take this interface and we say you belong to rect I think rect ret 1, of course, right? And then we say, well, you are ret 1, you belong to redundancy group 2. Whereas for this, we'll say you belong to redundancy group 1. Okay? Now I'm going to say for redundancy group 1, you are the primary. Why? Right? Why you are the secondary. Right? For redundancy group 1. Okay? Then for redundancy group 2, we are going to say here, you are the primary. Why this is the secondary for redundancy group 2. Okay, so what is the implication? The implication is that traffic going from your LAN, from these servers, will hit the TOR switch, go through our primary, right? For redundancy group 1, the traffic goes out to the internet. Okay, but the return traffic comes back in, right? Comes through the secondary, back to the TOR switch, and then to the server. Okay, so that's what you can have that kind of implementation. Okay, and it's still going to work perfectly fine. Okay, so there will be replication between both devices for the different redundancy group. So for the primary, he will always replicate his configs to the secondary for that context or for that redundancy group. Okay, and also for redundancy group 2, he's going to replicate the information back to the secondary as well. Okay, so it really depends on what you want to implement, or which is much easier for you to implement, but that is how you implement clustering for the SRX device. Now, by default, you have the redundancy group 0. Okay, redundancy group 0, that is there by default. Now, redundancy group 0 is where you have your management connections and the fabric link. Okay, now this fabric links by default belongs to the redundancy group 0. So you cannot create another redundancy group 0 because it's already there by default. Just like the ASA, you have your default context, which is like the routed where everybody belongs to. Okay, or default VDC for NXOS, or what did FortiGate call it? Is it VDOMs? I mean, it's the same. It's just the same technology across the different equipment that you have. I don't know what Palo Alto calls it. Yeah, so different vendors have different ways of classifying these implementations. Okay, so that is it. I think we've talked about everything that we need to cover. So let me zoom in a bit. Let's have a little deep dive into the connections. Maybe, yeah. Okay, so here you say this is the management. It's just for management, right? This is the management connections. Okay, called the EM0. I think it's maybe internet management. Okay, yeah. Now for physical hardwares, so let's say this is the SRX device. Okay, you might not have this management port for synchronizing the control plane. This management is where the control plane they are synchronize their control plane. Okay, so what usually happens is you are going to have different ports. It could be 10 gig port, it could be 1G port. Okay, and this physical port. Okay, now I think there is yeah, so for this physical port, what you do is usually this port here will be GE0/0/0 if it's a gig group, right? So GE0/0/0, maybe something like this. So what happens is the moment these two devices joins a cluster, right? So what you usually have is you can have like a regular switch here. Okay, so this connection comes here, right? And this connection too will come here. Okay, and then from here it can of course go into your management network. Okay, your management network or OOB network, and then somehow maybe you are coming in through VPN, and then you're able to access, right? So that is how the control link is actually set up. Okay, so whatever VLANs you are using here is just I mean that's basically the layer 2 switching. Okay, so these two devices see each other and they form this control link connections the moment you ask them to join a cluster. Same thing applies to the fabric link. Okay, for the fabric link, it's still the same thing. Now the fabric link can only be physical ports. Okay, so we can say that we are using this port as a fabric link. Okay, we can decide to use 2 because, like we said, data traffic actually goes through it. Okay, and then up to the second device. Okay, so this switch to perhaps needs to be redundant, right? But in this case, we are just using the SQL switch. It could be redundant, maybe like if you are using Juniper EX switches, you can put them in virtual chassis. Okay, so that's what you have. Now, what you need to know about the fabric link is transparent. Okay, transparent means you don't put IPs, you just tell them it's layer 2, basically transparent. Okay, you don't need to put IP, you just need to specify the port that, oh, this port is what I'm using for, right? So within the code, there's a way they replicate this information across. I think it's the same thing for the ASA, right? Which they call the failover link, or there's a particular port you can use for replications. Okay, and you just need to say these are the connections. Okay, now like I said, you can't bundle this link. At least from my own testing, when you try to add them to a bundle, it has to be physical interfaces because it's really transparent. Okay, yeah, I think that's what we need to do. Then of course you can now pick the other ports for maybe your LAN, right? So you can pick this as your LAN, and then you can pick whatever ports you want for the WAN connections. Okay, so one connection goes to the internet. So that's really a high level view of what we need to do. Now, having this basic knowledge, we now need to quickly build up the topology, and then let's see how we can implement that on if ENG. Okay, so let's zoom in now to just have a quick look at the physical connection. So this is the low level design. Okay, so here you see we are using port 0 to 4. So that makes it 5 physical ports is what we need on both devices for this implementation, right? 0 to 4. Okay, on the switch, we're going to need a lot of ports. So what we're just doing here is just to tell you. So now, you see this is fabric 0, these two connections. We call it fabric 0, and this is fabric 1. Okay, now you can have, I think maybe you can have fabric. Now, I don't think you can have, maybe you say here fabric 0 and then you say fabric 1. It won't work, right? You can't say here fabric 1 because the fabric 0 and fabric 1 have to be point to point. But I think here you can also have fabric 2. Maybe this end will become fabric 3. Okay, something like that. I don't know. I'm just saying maybe it's possible. I don't know, right? Maybe if we can try it, but basically what you always have is the fabric 0 and fabric 1, and you can have as many interfaces as you want. So I don't think this exists, but maybe we can try it. I don't know. Okay, so that's the physical connection. So port 0, like I said, is left for management. We don't need to do anything. We just need to connect them together, and then poof, management comes up. Then here we need to specifically tell the devices that, oh, we are using these 2 ports for the fabric link. Then of course we need to configure the LAN and wide area link. Now for the wide area and LAN connections, we need to create rect interfaces for them, just like we earlier said. Okay, so here we are saying this is rect 1. Therefore the one link we can say you are rect 2. Okay, or we can say rect 0. There's no relation between rect 0 and redundancy group 0. No, they are 2 different things entirely. This is an interface. This is a redundancy group. Okay, so it doesn't mean there's a default rect 0. That's what I'm trying to tell you. It doesn't exist. Okay, so we can say here you are rect 0, here you are rect 1, and then we tie them to the same redundancy group. We should be good. So we're using port 11 and 12 for the connection to the 2 servers behind, and then we're using port 3. Remember, we're using port 3 for the wide area network connections, and we're using port 4 for the LAN connections. Now, something else we'll need to talk about is the situations whereby the LAN connection is actually a port channel. Okay, so depending on your data center, you definitely want to have redundancy for the LAN connection. Okay, so it means what happens is this. So let me try to sketch it here. So I have two switches. Let me pick a red, which is much more visible. Let's scroll down to where we have page. Okay, so let's say I have two SRX devices, okay, that are in a cluster. So SRX A, SRX B, okay, and then I have my switch. Okay, now I have two connections that comes here, okay. So this is our rect interface. Okay, we're going to call it rect 1. So here too it's rect 1 from the firewall perspective. But the question is so here we are bundling, right? So we are saying for rect 1 we are bundling the connections, right? Okay, remember it's not two separate bundle actually. So what is really happening is you are bundling the connections like this, okay, because these two devices are actually one physical device. But the question is, on the switch, can we also bundle this connection like this? Okay, so whether it's one physical connections to each of the switch or different, can we bundle? If you bundle it this way, remember this switch will see these two devices as one single device. So if I have a server here, when the traffic comes, let me connect. So what happens is, if the traffic comes, the traffic gets to the switch sees both devices as the same, and they are the same port channel. So what happens is traffic goes this way, and traffic also goes in this direction. But remember, this device is standby. So what eventually ends up happening is whatever traffic is forwarded here gets dropped while this goes out, and then it will definitely not work. So what we need to do is we need to let me see here, not what I was planning to do. Well, let me see if I can erase something here. Okay, so what we need to do is we need to have separate bundle channels, okay, at the switch level. So here it's just one port channel, right? But on the switch level you need to have two separate channels. So here could be port 10, where here will be port 20, okay? So that when the traffic comes, there's APP request that goes to the two devices. Whoever responds is what gets forwarded, okay? And so this port channel will be up but on standby while the traffic goes through the primary to the internet. So that's something you need to take note of when you are implementing clustering for the SRX. So I believe we have covered everything that we need to cover. So in the next video, we want to begin the lab setup. So we will need to go to ENG, right? And then we begin the implementation. Okay, so see you in the next video. If you like this video and you want to see more content like this, where we try to simulate real world environment and have hands-on experience on some of these technologies across different vendors, you might want to subscribe to this channel so that whenever I release upload new videos, you get the notifications, and I believe you'll be able to benefit from it. Okay, see you in the next video.